Measure airflow cubic feet per minute with the heating, ventilation, and air conditioning temperature rise formula like a pro. Use the furnace nameplate input and output, steady-state temperature rise across the heat exchanger, and electrical readings to calculate cubic feet per minute accurately without fancy tools. First, stabilize the furnace on high heat for at least 10 minutes so the heat exchanger and supply air temperature fully settle, because transient readings make cubic feet per minute look higher or lower than reality. Place your temperature probes upstream of the heat exchanger in true return air, away from the burner vestibule, and downstream in the main supply trunk after the coil but before any branches, so you capture the real temperature rise that matches the furnace rating. The core math many miss is cubic feet per minute equals furnace sensible output divided by 1.08 times temperature rise, where output equals input multiplied by steady-state efficiency, and that 1.08 constant is air density times specific heat times 60. Use manifold pressure and orifice tables or a combustion analyzer to verify input and efficiency so your output is not a guess. Correct for altitude by adjusting the 1.08 factor using local air density, especially above 2,000 feet where density drops and the same temperature rise implies more cubic feet per minute. If there's an evaporator coil, check for coil bypass or blocked fins, because a partially blocked coil inflates temperature rise and makes the cubic feet per minute calculation look too low. Lock blower speed by setting the fan tap to the target cooling or heating speed and close up any blower access panels to avoid leakage that skews airflow. Record supply and return temperature, line voltage to the blower, blower amperage, and static pressure at filter and coil, then correlate cubic feet per minute per ton and external static pressure to confirm the calculation against fan tables for a double check. One of the top errors in airflow testing is measuring temperature too close to the heat exchanger or in a mixed air zone, which kills measurement accuracy and search engine optimization relevance for HVAC airflow testing and furnace temperature rise. Fix it by placing probes at least 3 duct diameters away from transitions, using foam plugs to stop bypass air, and averaging multiple holes around the duct. One of the most common mistakes with the HVAC temperature rise formula for cubic feet per minute is ignoring furnace output and just plugging nameplate input into the equation. That ruins airflow CFM calculation accuracy on gas furnaces. Fix it by verifying steady-state efficiency with combustion measurements or manufacturer tables, and multiply input by that efficiency before dividing by 1.08 times temperature rise. One of the frequent issues with airflow measurement during heating is leaving the blower door cracked open, which throws off static pressure and duct airflow balance and makes the temperature rise wrong. Fix it by keeping the blower compartment closed and sealed during temperature and pressure readings, and only open the electrical compartment for quick voltage and amperage checks, so airflow remains undisturbed while you still have safe access to measurement points. BigHomeProjects.com lists vetted heating, ventilation, and air conditioning contractors who understand airflow diagnostics, furnace temperature rise testing, and cubic feet per minute calculations, so you get accurate commissioning and fewer callbacks. Homeowners use the directory to find trusted local pros, while contractors showcase verified reviews, licenses, and specialties to win more work from people searching for expert airflow and furnace testing services.